Good day, students. On this clip, we're going to be going over how to find inverse of different functions and verifying the accuracy of our solutions by composition. Okay, so let's write down the title for this lesson: Finding and Verifying Inverses. Finding, write that in uppercase. Finding and verifying inverses. Finding inverses. All right. Let's take a look at. I'm going to take a look at 3 examples. The first example is as follows. So the instruction is find the inverse. Find the inverse f to the negative 1 and verify the accuracy of your solution by composition. Okay, so that's what we're going to do. Alright, number 1, example 1, consider the function f of x equals 3 times the square root of x to the third plus 2. Okay, so let's try this one out. So for this one, let's see. To find the inverse, it's a 3-part process. So let's delineate the parts. So I'm going to call this part 1. Part 1, you're going to find the inverse, which is f to the negative 1. That's the inverse. So for symbolic convenience, I'm going to write f of x as y, right? So I'm going to write it as y equals 3 times the square root of x to the third plus 2. Okay? So to find the inverse, remember what you do is you switch and you solve. You switch and solve. Switch the x's and the y's, solve for your new y. That will be your inverse. So let's switch first. We're going to switch the x's and the y's. So you're going to have x equals 3 times the square root of y to the third plus 2. What did I just do? I just switched the x's and the y's. Now I'm going to solve for my new y. That will be my inverse, okay? So to get that, I'll divide by 3, square both sides, minus 2, and take the cube root. Alright? Like reverse PEMDAS, get rid of the 3, the root to 2, and then that 3 there. Alright? So let's do it. First thing I'll do, divide both sides by 3. Or by 3, divide by 3. And then we're going to have x over, wrong color. We're going to have x over 3 equals the square root of y to the third plus 2. Okay, so what's the inverse of square root? Inverse of square root is square, right? So I'll square both sides. Alright, and now I'll square both sides because the inverse of square root is square. Square this side, square this, and then square that. So that's going to give me, on the left side, x squared over 9 equals y to the third plus 2. Because the square and the square roots cancel out. So y to the third is 2. Okay? Now, let's get rid of the 2 and this cube. So 2 goes first. Subtract 2 from both sides. You're going to have x squared over 9 minus 2 equals y to the third. Alright, so what's the opposite of cube? Opposite of cube is cube root, so we're going to take the cube root of both sides. So you take the cube root of the left side, and then the cube root of the right side. Alright? So this cube cancels out that cube right there. So you're going to have the y, which is f inverse, alright, that's f inverse, is going to be, or f inverse of x is going to be the cube root of x squared over 9 minus 2. Okay, so this is f inverse. So the question now is this answer that I have, this f inverse, is it correct? So I have to show that my answer is accurate. So that's f inverse. So we just finished part 1. Now we're going to do part 2 and 3 to verify that our inverse is actually accurate. Okay? Alright, let's start off with part 2. Let me partition my workspace like so. Part 2. So the question of part 2 is as follows. Part 2. Part 2 we have to show, we have to answer the question, is f composed with f inverse equal to x? Is it? If it is, then we'll advance to part 3. In other words, if I plug f inverse into f, the original problem, will I get x? If I do, then that's good. Alright? So what's the parent here? The parent is the first function, which is f of x. So we're going to write down the parent function first, f of x, which is equal to 3 times the square root of x to the third plus 2. Now we're going to substitute our inverse into that and see if we get x. Okay, so let's get the parent prepped. So f parenthesis equals 3 times the square root. I'm going to make my square root pretty big right here because our input is going to be a little bit big. Times the square root of, instead of x, I'm going to put parenthesis square, a parenthesis cube plus 2. What did I just do? I just got the parent prepped for this input function. Okay, this is going to be my baby function that's going to get inputted here because it comes second. So the name of my input is f inverse of x. The value is going to be this. So the value is going to be the third root of x squared minus 9, no, x squared over 9 minus 2. Okay? So there is your input function. Okay, so I put that in the parentheses plus 2. Okay, so I took this x out, replaced it with parentheses, and I took the inverse and I plugged it into the parentheses. Now if I simplify this, will I get x? Let's see. First, the cancellation, you just do one cancellation per line. Cube and cube root are inverses, so this and that cancel out. So you're going to be left with 3 times the square root of x squared minus 9 minus 2 plus 2. What happens next? This 2 and this 2 are inverses, so they cancel out. And you're left with 3 times the square root of x squared over 9. Square root of x squared over 9 is going to be 3 times x over 3 because you square root the top and the bottom. It's x over 3. 3 and the 3 cancel out. The final answer is x. So that checks out. So part 2 checks out. Alright? So now we're going to do one more part 3. So let me see, can I fit it in that space right there? I might be, but let me just put it on the bottom so that I don't get confused. So part 3 is as follows. The question for part 3 is the reverse composition, is f inverse composed with f equal x? If I take this, if I take the original answer I had, the original problem I had, and I plugged it into the answer, into this inverse, do I get x? So that's the question. We're going to do what we did here, but we're going to switch the functions around. Alright? So, what is the parent here? The parent here is an inverse function. What is the inverse function? There goes the inverse function right there. So let's write it down first. Always write down the parent so that you can get your work nicely organized and not get confused. This is part 3. So the parent function is the cube root, not 3 times the cube root here, okay? The cube root of x squared over 9 minus 2. Alright, so let's get this parent function prepped. Replace all the x's with parentheses. and then 3. Next one, flip here. So I know that my input function is going to be a little bit big, so let's make the parentheses square root long, okay? So how big is my input? Oh, it's just long, it's not big. Alright, so it's just that one. So it's going to be parentheses, make it long enough, square, over, over 9, parentheses square over 9 minus 2. Okay? Alright, so we have it prepped now. What is the name of my input function? The name of my input function is f, right? Because that's what's going in this time. That's the input. Now what's the value? The value is the original problem, 3 times the square root of x to the third plus 2. So it's going to be 3 times the square root of x to the third plus 2. Okay? Alright, let's simplify this. To simplify this, first thing we're going to do, you notice this square here? We're going to have to distribute that square to the square root and do the 3 in front. Okay? Because it's inside the parentheses. So let's go ahead and do that. So the third root of, upon distribution, we're going to have, what's 3 squared? 9, right? 9 times, when I square a square root, squares are inverses. So they cancel out. So it's just going to be left with x to the third plus 2. Alright, so we distributed that 2, so that cancels, this becomes 9, and then the square cancels the square root. So we have this whole expression here divided by 9 minus 2. Okay? Alright, so if you notice, this 9 and this 9 cancels out. This cancels out with that. It's going to leave us with the cube root of x to the third plus 2 minus 2. The 2 and the 2's cancel out, and then we'll have the cube root of x to the third. Since cube and cube root are inverses, they will cancel each other out, and left with x, which checks out. So we have to write a conclusion to our proof. So since f composed with f inverse is equal to f inverse composed with f, which is equal to x, then f inverse of x, which is equal to, what did we get? Cube root of, oh yeah, I forgot. The cube root of x squared over 9 minus 2 is the inverse. Of f. Okay? And your story with a little box, that's period. So that shows that that's what our inverse is. Alright, let's take a look at another example. A little bit more intense than this. This one is a little bit easy. So let's take a look at the following. Example 2, same process. Example 2, what if we had f of x equals 3x plus 2 over x minus 2. Let's say we had that, okay? So first thing we want to do is find the inverse, part 1, and then part 2 and 3 is verification. Okay, so part 1, find f inverse because of x, okay? So how do we do that? So let's rewrite this function using y, so it's easier to switch. So I'm going to write in y equals 3x plus 2 over x minus 2. Now we're going to switch and solve, okay? Switch your x's and your y's. So we switch, we're going to have x equals 3y plus 2 over over y minus 2. Okay? Over y minus 2. Now we just switched. Now we're going to try and solve for y. So y's are all over the place, so we need to collect our y's to one side, okay? So write this as a fraction, we're going to cross multiply, okay? This goes to the up, this goes to the top, so we're going to times these two together. So cross multiply bottom up, bottom up. like that. Okay? So for multiply, we're going to have on the left side x times y minus 2 equals 3y plus 2, because 3y plus 2 times 1 is an identity, right? So just 3y plus 2, that's what you have left. Distribute this x to both of these terms, so you're going to have xy minus 2x equals 3y plus 2. Now, we need to collect the y's to one side, factor it out, and then isolate it. So I need this y term and this term with a y, I need them on the same side. So how about I move this to the left and move that to the right? So to move this to the left, I subtract 3y from both sides, right? Subtract 3y from both sides. And then to move this to the right, I can add 2x to both sides. Add 2x, add 2x. Just do a switcheroo. So you're going to have xy minus 3y equals 2x plus 2. Okay? Now let's factor out a y from the left side. If we factor out a y, we'll be left with x minus 3 equals 2x plus 2. Alright, now to finally isolate y, I need this additional component here gone. Okay, so I need to divide both sides by x minus 3. So divide this one by x minus 3, and divide this one by x minus 3. These two cancel out. You will be left with y equals 2x plus 2 over x minus 3. Oh snap, I should have written that as f inverse. So anyway, that is basically your f inverse constructed. F inverse of x equals 2x plus 2 over x minus 3. Okay, now that we have the inverse, we are going to verify that our result is accurate. Now, how do we verify that our result is accurate? We're going to do this with the use of composition. Okay? Alright, so let's do part 2 and 3. Part 2 is as follows. Write this down. Let's partition our workspace so we do not get confused. Part 3. Part 2, Part 2. The question is f composed with f inverse equal x? Is it? Question is, if I take this one and I plug in the inverse into it, do I end up with x? If I do, then I'm looking good, and then I'm going to go part 3 and try to reverse composition, okay? So to start off, you're going to write down the parent function, which is f of x, right? So f of x is basically 3x plus 2 over x minus 2. Now we're going to get it prepped, okay? What does that mean? That means that I need to clear out the x's in preparation for the input function. So I'm going to write f parentheses equals 3 times a pretty big parentheses plus 2 over a pretty big parentheses of the same magnitude at the top minus 2. So what did I just do here? I just got the parent function prepped to have an input function or baby function, which is f inverse. Okay? So what's the name of the input function? You said it, f inverse of x. What is the value of the input function? The value is 2x plus 2 over x minus 3. So that goes here. So 2x plus 2 over x minus 3. And then 2x plus 2 over x minus 3. Okay? Alright, so they have it. So now, I have a denominator in the top and the bottom. So an easy way to get rid of that is to multiply the numerator and the denominator by the LCD of those two fractions. Since the denominator is the LCD of the denominator, since the denominator is exactly the same, I'll just multiply top and bottom by that, okay? So I'm going to multiply the top expression by the denominator, which is x minus 3. And then I will also multiply the denominator by the denominator, which is x minus 3. The goal here again is to eliminate this denominator here and this denominator here. Okay? So what I'm going to do, I'm going to take this x minus 3 and distribute it to this term and distribute it to this term. Okay? Same story at the bottom. Take this, distribute it to that, and also distribute it to that. Alright? Let's go ahead and do what I just said. Distribute that to all the terms. So that's going to give us 3 times 2x plus 2 over x minus 3 times x minus 3. That's this distributed to the first one plus 2 times x minus 3. That's x minus 3 distributed to the second term divided by, same thing we're going to do on the bottom, okay? It's going to be parentheses 2x plus 2 over x minus 3 times x minus 3 distributed to the first minus 2 times x minus 3 on the top into the second term. So this to that gives you this to that gives you that. Okay? Alright, let's take a look at this for a minute. What can we do here? If you look on the left side, you notice that this and this match, right? That's what I wanted. I wanted them to match so they can what? Cancel. So this and this cancel out, just to 1, 1. Same story in the bottom. This and this cancel out, just to 1 and 1. Alright? So let's simplify it. We simplify, we're going to have 3. We can just distribute this 3 to these two, huh? So why don't we just distribute what we're adding? So it's going to be 6x plus 6. And then we can distribute this 2 to these two terms. Plus 2x minus 6. Divided by, on the bottom, 2x plus 2. And then distribute this negative 2 to both of them. Be careful, this minus is going to change this sign here, okay? So it's going to become minus 2x plus 6. Now what happens in the top? In the top, on the numerator, these are opposites, they cancel out. So we're going to have 8x on the top. In the denominator, these two are the opposites, so they cancel out. So we have over 8 in the bottom. What is 8 of x over 8? 8x over 8 is just x. So part 2 checks out perfectly. Okay? Alright, we have part 2 done. We don't know. We need part 3. Okay, so part 3 is as follows. Write this down. Part 3. Part 3, the question is the reverse composition is f inverse composed with f equal x. Is it? If it is, then we're done, because composition of both directions yielded our desired result, which is x. So let's do this verification. We start out with the parent function, which is the inverse in this case. The inverse function is what's staring at you right here, 2x plus 2 over x minus 3. Now let's get this function correct to receive an input function, okay? So to get it correct, we pull out the x's. So we're going to write f inverse parentheses equals 2 with the parentheses big enough to accommodate the size of f, which is a rational expression. So let's make it that big. Plus 2 divided by parentheses minus 3. Big parentheses here, minus 3. Alright. So what is the name of our input function? The name of our input function is f of x, right? And then what's the value? The value is 3x plus 2 over x minus 2. So 3x plus 2 over x minus 2. Okay, that's the input. And then same thing on the bottom. 3x plus 2 over x minus 2. Okay? Alright, I have the same scenario that I ended up with up there, over here. So I'm going to use the same trick, okay? So in this case, the denominator is x minus 2. I don't like these fractions. I want to clean them out. So what I'll do is multiply the numerator and the denominator by the LCD of the denominators. Well, those both denominators are the same, so I just multiply it by just that, right? The LCD is going to be x minus 2, so I'm going to times x minus 2 to the top and the bottom with the goal of eliminating this denominator right here. Okay? So putting an arrow, this gets distributed to that, and this gets distributed to this. Same story at the bottom. This gets distributed to that, and this gets distributed to that. Alright, so let's go ahead and simplify this. So we'll simplify this. We're going to have 2 times 3x plus 2 over x minus 2 times x minus 2 plus 2 times x minus 2. Divide the whole story by 3. Sorry. Divided by 3x plus 2 over x minus 2 times x minus 2 minus 3 times x minus 2. Okay? Now you notice that we can have a cancellation action going here. So this one cancels with that. This one cancels with that. What we're left with, we can distribute and simplify. So this distributes to that and that. This distributes to that and that. And this distributes to that and that. Okay? Alright, let's go ahead and do the distribution. Hopefully this one works out. So on the top, we're going to have 6x plus 4 plus 2x minus 4 for the numerator. And then for the denominator, we're going to have 3x plus 2 minus 3x plus 6. Notice that this minus times this minus makes that a plus. So we're going to have, what are we going to have? We're going to have 8x. Oh, these are opposite, so they cancel out, huh? So 4 and 4 cancel out. This cancels out. And then these 3x's cancel out. So we're going to have 8x over 8. Yes, 8x over 8. So this and this cancel out. Final answer is x, so it checks out. Okay? So we're going to write down our concluding remark. We're going to say that since f composed with f inverse equals f inverse composed with f equals x, then f inverse of x, which was 2x plus 2 over x minus 3, is the inverse of f. And put your little box of accomplishment there. Alright? So there you have it. Alright, hopefully you have energy for one more example. It's going to be short and sweet. Let's try one more out, and then we can get started on the classwork for today. Alright? So let's try this. Give it a minute. Clear out. So long problem, so it's going to take some time to clear. Okay. So example 3. This is shorter. Example 3. Same story. Let's say f of x is the third root of the tangent of 3x. Let's say we have that. So let's do the same story. Let's find the inverse and verify. So part one. Find the inverse f to the negative 1 of x. Okay? So we're going to write y equals the cube root of tan 3x. Okay? So to find the inverse, first thing we're going to do is we're going to switch the x's and the y's. So you're going to have x equals the cube root of tan 3y. Okay? Now let's solve for y. That will be our inverse. So how do we solve for y? Get rid of the cube, and then the tan, and then the 3. What's the opposite of cube root? Cube root? Opposite of cube root is third power of cube. So make cube both sides. So you're going to have x to the third equals tan 3y. What is the inverse of tan? the inverse of tan is an arctangent or inverse tan. So we're going to take the inverse tan of both sides, inverse tan of x to the third equals inverse tan of tan 3y. Okay. So on the left side is tan and this inverse tan and inverses, they cancel out. So we're going to have inverse tan of x to the third equals 3y. To get y finally isolated, which is our inverse, we divide both sides by 3. So divide by 3, divide by 3. And then we'll end up with the inverse, f inverse of x, to be this whole business right here, which is the inverse tan of x to the third over, not like that, over 3. Okay? Inverse tan of x to the third over 3. So there goes your inverse. So the question is it correct? Well, let's see. Part 2. Let me see if I can put all the 3 parts next to each other in this example. Part 2. The question is f composed with f inverse equal x? Is it? Well, let's see. So f of x is the parent because it comes first. We write it down, which is the third root of tan 3x. Now we're going to get it prepped. Replace all the x's with parentheses. So f parentheses for the name on the left side. On the right side, the cube root of tan of too much. Cube root of tan parentheses, I want to use bracket, tan parentheses 3 times parentheses. Okay, so what's the name of my input function? The name of my input function is f inverse, right? So put the name on the left side. And then the value is this whole story here, so put that in here. So it's going to be tan to the negative 1 of x to the third over 3. Over 3. Okay, so just rewriting that in here. Okay? So now what happens first? If you notice, this 3 and this 3 cancel out because you're tripling that, and then you're gonna end up with the cube root of tan of the inverse tan of x to the third. Close that, close that. Tan and inverses, so they cancel each other out, they're inverse operations. So you'll be left with the third root of x to the third. These are inverses, so they cancel each other out again. Final answer is x. This checks out. So part 2 is good. Yeah, so let's try the last part, part 3. Part 3 is the question is the inverse composition going to yield the same result? That's the question we're asking ourselves. Is the inverse composition going to yield the same result? So part 3 is f inverse composed with f equal x. Is it? Let's start with the parent. The parent is f inverse this time, right? Which is what we got here. Tan to the negative 1 of x to the third over 3. Alright? So, let's get it prepped. So we're going to have f, parenthesis for the name, equals, I'm going to get myself into trouble here now, equals inverse tan of parenthesis to the third, close that, and then that whole thing divided by 3. Okay? What did I just do? You notice that the x was inside the inverse tan parenthesis, right? So this x is gone. I just put a big parenthesis here to clear this x inside the parenthesis out. because that's going to take the input function. Alright, so what's the name of my input? F. This is f to the negative 1. So my input is f, so I'm going to put f on the left side, f. And then the value of f is the original problem, which is this, which is the third root of tan 3x. Third root of tan 3x. Okay? So let's see if we can simplify that. The third root and the cube cancel out, so this and this cancel out. So you're going to be left with the inverse tangent of tan 3x over 3. Alright? Tan and inverse are inverses, so they cancel out. So you're going to be left with 3x over 3, which divides out into x, and that checks out. Good, so we can now write a conclusion. So since f composed with f inverse is equal to f inverse composed with f is equal to x, then the inverse we derive f to the negative 1 of x, which is the inverse tan of x to the third over 3, is the inverse of f. Okay? Excellent job paying attention. Put your little box of accomplishment here to show that you're done with your proof. Okay, now we're going to go ahead and try some problems. Remember, these videos uploaded on YouTube for your viewing pleasure.